Hi, I'm Adam. Welcome back to Godot Game Lab. In this video, we'll add the first iteration of units to the game. As you can see, we have a couple of units here on the game grid with the health bars and mana bars. We also implemented a reusable and flexible drag and drop component which we added to units, which means that I can left click and start dragging this unit around and can let go of the left mouse button to drop it. Or if I start dragging this other unit, and press right click while dragging it and keep moving the mouse, I can cancel the dragging movement and stop dragging that unit. We also make sure that when a couple units overlap and pretty close to each other, we can only drag one unit at once. So if I press and hold left click, only one of these units can pick up this signal. To make sure that we can't overlap and we can only drag one object at once inside our game. And before we jump into implementation, let's talk about architecture. So there's not much of an architecture going on here for the unit itself, but why not talk about how we stitch together all the pieces here? So the unit scene itself has three major pillars: its nodes, its data, and its components attached to it. So we have a bunch of nodes here, but we won't be adding all of them in this video because there are some which are related to specific components. In terms of data, we have one resource called UnitStats, which stores information like the name of the unit, the gold cost, the skin or the graphics attached to it, and so on. And we also have three components: the drag and drop component, the velocity-based rotation component, and the outline highlighter component. In this video, we'll focus on the basic nodes, the unit stats, and the drag and drop component. So how does this drag and drop component works? Well, we'll define three signals: when the dragging started, when the dragging was cancelled, and when the target is dropped. And also it's pretty configurable because we can set it to any target. In this case, the target will be the unit itself, but in season 2, we'll reuse the same component for items. So why don't we get started? So I have the project open here from the last time. And before we jump into creating the new unit scene, let's fix a couple issues first from the previous episode. As it was rightfully pointed out by one of the viewers, when we select the highlight layer under our bench, you can see that it's not in the right position. It's supposed to be in the top left corner of the bench. So let's go into move mode by pressing W and then just drag and drop it over the right place. Let's go back to select mode by pressing Q and let's save the scene with Ctrl S. Okay, so that's one thing fixed. Another, well, it's not an issue, but something that bothers me is that these props and bushes and flowers and also these puddles of blood are a bit too distracting for my liking. What we can do is we can select those layers. Let's do the props first. And we can go to visibility under canvas item and set the modulate property and set it to something like this. And if we click back on the arena node, the root node, you can see that it's much less distracting, right? And we can do the same for the decor layer under our game area node. Go to visibility, modulate, and set a lower alpha value. Maybe something like this. I think it looks much better and improves the visual clarity of the project. Awesome. We can save the arena by pressing Ctrl S. One more thing we need to do just before actually starting creating the unit scene is attaching a script to the arena itself. So with the root node selected, click on the attach script button and arena.gd is perfectly fine. So we can click on create. And we need to do two things here. First of all, we'll give a custom class name called arena to the script. And then we define a bunch of constants which we can reference throughout the whole project. So if we need the cell size of the game for whatever reason, or the half of it or the quarter of it, we can reference it from this arena class. And this is good because when you're done with the project, you might decide that I don't really like this asset pack or tile set I'm using. I want to switch to a different one, which might have a different cell size, right? And so then all you need to do is to change these constants and also reconfigure your tile map layers or tile set data, and then you're good to go. So we'll be referencing this throughout the whole project. For this video, we'll use this for the drag and drop component. And with that done, we can save the script with Ctrl S, and we can go back to 2D view, Click on the plus sign next to the arena to create a new scene, and we can start creating our unit scene. Okay, so we need to decide about our root node, right? So what do we need for the units? Well, it's gotta be a 2D scene, right? Because we'll have a sprite attached to the units to display them in the game world. Yes, and what else do we need to do with the units? We need to be able to hover them, drag them around, swap with other units, and so on. Which node makes it possible for us to pick up input signals or input events for a 2D node? That's right, the area 2D node. So let's click on other node for the root node and search for area 2D. Press enter. Let's double click and rename this to unit. And we have this configuration warning because area 2D nodes need collision shape 2Ds to work properly. So let's press Ctrl A to add a new child node and search for sprite 2D first because we need an image for the units, right? Press enter, select the root node again, press Ctrl A to add a new child node and search for collision shape 2D. Press enter again. And now we have a new node configuration warning because there's no shape resource attached to this collision shape. We'll get there, but let's add all the nodes first, right? So let's click on the unit root node again, press Ctrl A, and we'll add 2 progress bars for the health and mana of that unit. So let's search for progress bar, and we'll use basic progress bars for this with solid colors. So let's press enter. Double click and rename this to health bar. Press Ctrl D to duplicate it, click on it and rename it to mana bar. And now we can start actually filling in those properties. So for the sprite 2D, let's go to the texture property, click on the arrow, click on load. And from the assets folder under sprites, we have this image called rogues.png. Let's double click on this one. And you can see that we have a bunch of sprites available here. But if we go under region and click on enabled, we can click on edit region, toggle the snap mode to grid snap, and set the step size to 32 by 32. If we zoom in, now we can select any of these units. I just select this warrior here with the mouse and click on close. And now we have our unit. Let's offset the unit a little so it's not perfectly centered to the grid because this will make it look weird if we sit it on the bench. I'll show you in a second. So let's first of all save this scene by pressing Ctrl S. In our scenes folder, we can create a new folder, call it unit, and save this as unit.tscn. We can also rename the sprite to something like skin, because we have one image for all the rogues and we can just kind of mess with these coordinates to get the image we want. And if we save this and go back to the arena scene, we can instantiate a new child scene by pressing Ctrl-Shift-A or clicking on that button. If we select unit.tscn, you can see that if I go into move mode by pressing W and start dragging the unit, you see if I position it to the first grid on the bench, it's in the correct position, but it would be much easier to work with this if the unit was a bit offset compared to this position. But this coordinate is fine because it will be the same or equal to as a tile position. I just kind of want the image or the visual of the unit to be offset by some values to make it look a bit nicer, right? And we don't really have to guess these numbers. A cool trick you can do for work like this is you can right click on this unit and toggle editable children. And you'll see all the child nodes under this unit. And we can click on the skin, go to transform, and we can mess with the position to get a value we like. So if I press and hold the left mouse button on X, I can start dragging it around. And you'll see that this kind of looks nice, right? And you'll see that this is 15.48. So my guess is that by offsetting with half a cell, it would look nice. So let's change this to 16. And do the same for the Y. I'll start dragging the mouse. And this kind of looks nice, right? It's not perfectly positioned to the bottom, but I don't really want that because that would look a bit weird if I do that, right? It looks a bit weird. I think it looks cooler if the unit is kind of in the center of a cell. So maybe that's quarter of a cell, right? So let's change this to 8. And if we zoom out a bit to see what it looks like, it looks kind of nice. But we only offset the skin, right? Because this is the skin node selected. The unit is still at the same position the bench is. And this is awesome because tile coordinates refer to these top left corners. So we can always use those coordinates to position the units from code later on. Okay, so if we're happy with this offset, we can delete this instance of the unit scene from here. And if we go back to the unit scene, we can actually change the skin's transform here as well. And it was 16 by 8 pixels. Awesome. So let's save this with Control S. Go back to select mode by pressing Q. And we can do the collision shape next. And it's important that we do this right because this collision shape will be used to pick up the input from the mouse for dragging, for example. So let's click on the shape property and create a new rectangle shape. You can use a circle or a capsule if you want to. I think for this one, a rectangle works perfectly fine. And if we click on that shape, we can change the size. I use 36 by 36 to make sure that it's a bit bigger than the actual cell size for the unit. And we can go into move mode by pressing W. And if I start moving, you can see that grid snapping is turned on, so it won't work properly. But if we expand transform, you can see that if I move it here, that's 32 pixels offset. And if I move it down, that's 32 as well. If you don't want to do the calculations, you can just turn off the grid snapping and position it however you want to. I just use the same offsets I used for the unit sprite. So 16 by 8, I think, works perfectly fine here. So we can turn back grid snapping. Again, we can save this by pressing Ctrl S, and we can do the health bar and the mana bar next. So we can select the health bar, and the first thing we want to do is to uncheck show percentage. Then we can go under theme overrides and styles and change the background and the fill style for this progress bar. But in order to see what's going on better, we can hide the mana bar for now because it seems like show percentage did nothing, but it turned it off. We just didn't see that because the mana bar was still visible. Also, let's make this progress bar wider to better see what's going on. And if we go into move mode by pressing W, we can just move it a bit up to see how it looks like. Let's go back to selection mode by pressing Q. And under styles, we can create new flat style boxes for the background and the fill. So first for the background, we'll create a new style box flat resource. And if we click on it, the only thing I want to change here is the background color for this style box. So let's click on background color. And I use this deep dark brown or reddish color for this one. And just to make sure that we have our colors saved to the game, we can click on swatches and click on this plus sign. So this color will be available for the whole project. Awesome. So we don't really want to change anything for the background. We can collapse this for now and add the new style box flat again, but this time for filling this progress bar. Again, if we click on it to expand it, we can set the background color first. So click on the rectangle and I'll use this lively green color for this one. And if we click on swatches, we can add this color to our swatch as well. So this is a really cool light green. And if we scroll all the way up and experiment with the value, right? So if I click and drag the mouse, we can see how actually changing the progress bar looks like. And I don't really like that there's no border for this, right? So what we can do is we can change the border width for the fill style box, change this to 1 pixel on all sides. And the cool trick we can do with the border is to set it to the same color we have for the background. So let's expand our border, click on the color, click on swatches and use the same brown color. And I think it looks much nicer this way. And our health bar is basically done, but it's way too wide and tall to look nice actually. So let's just collapse the style boxes and go to layout under control and transform and change the sizes. For the X, I'll use 30. For the Y, I use 6. And for the position, we can center it basically by moving it with 1 pixel and also bring it closer to the unit. So we can use something like -20, for example, like so. And you can see that it looks much nicer. It looks like a neat little health bar. And we can do the mana bar next. So let's click on the mana bar, toggle the visibility to make sure it's visible, uncheck show percentage. And we can actually start with the transform this time. So under control and layout, we can go to transform and set the sizes first. So I want this to be the same width as the health bar. So let's change this to 30, but we can make it a bit less tall. So let's change this from 6 to something like 4. And for the position, we can move it to -15. And for the X position, we can move it to 1. So it kind of aligns perfectly well with our health bar. If you want to, you can move it down 1 pixel. So by setting it to -14, you can make sure that they are not connected. But I kind of like the idea of sharing that 1 pixel border there, but we'll see how it looks like when we actually finish with the style boxes, right? So it will basically work the same way as the health bar does. So let's go to the theme overrides, styles, and add a new one for the background. And you know what? Yeah, let's just redo it. It's easier, but you could save the style box flat from the health bar and reuse it, but it's so simple to redo. It's just basically a color change. Clicking on the color and assigning the brown color we have under our swatches. And for the fill, we do have to create a new one either way. So create a new style box flat. And the background color will be a light blue for this one. And we can add that color as well to our swatches. And we do the same trick we use for the other one. We go to border width and set all the borders to 1 pixel. And set the border color to the same brown color we have for our health bar and the background. Awesome. So with this done, we can change the value to something like, I don't know, 70 to see how it looks like. And you'll see, yeah, it kind of works if we provide the space between them, but then we have 2 pixels right there, right? So I don't really like how this looks like. I think they are too far away from each other. So that's why I used -15 in my reference project, because with this version, they overlap on this 1 pixel, but I think it looks a bit cleaner this way. I don't know. Do whatever you like, I guess. So I'm happy with this one, and we can reset the mana bar to 0. And if you scroll out, we are basically done with the bare minimum amount of nodes for our unit, and we can save it by pressing Ctrl S. Now we can finally do some coding. But before we jump into coding the unit itself, let's do the data related to the unit first, right? The data container. So let's click on our file system's root folder, right click, create a new folder. Let's call this data. And in our data folder, right click again, create a new folder. We can call this units. And if we expand our data folder and our units folder is selected, we can right click and create a new script. And we can call this unit_stats like we usually do. And we can uncheck the template and make sure it inherits not from the node, but from the resource class. Let's create this script, expand the folder, and double click to open it up in the script editor. So what kind of stats we'll use for the units? In this iteration, we do the bare minimum, and as we expand our project and introduce new systems in our game, we'll revisit this UnitStats class a couple times. So first of all, let's provide a custom class name called UnitStats. Then we'll provide an enum for unit rarities, and we'll have something similar to Teamfight Tactics. We'll have common, uncommon, rare, and legendary units in the game. Then we assign colors for those different rarities in a dictionary. And we call this rarity colors, and the keys will be the enum values, and the values will be specific colors. Then we'll have an export variable for the name of the unit, which is a string. Then we'll have a new export category called data, just to keep things organized when we add units, which for now contains 2 values or 2 properties, one for the rarity of that unit and another one for the gold cost. Then we have another export category called visuals. And for now, we'll only have a skin coordinates here because we saw that the units are stored in a sprite sheet with this asset pack. So we don't have to actually store images. We just need their coordinates inside that sprite sheet, right? And we use vector2i here because the I stands for integer. So these are special vector2s where the coordinates can only be integer values, not floating point values, right? And then finally, we override the toString method for the resource. So when we print it out for debugging purposes, we'll just return the name of the unit instead of the default resource ID to make our lives a bit easier. And that's all we really need for now. So we can save this with Control S. And then we can go back to 2D view and attach a script to the unit itself. So let's select the unit node, the root node in this scene, click on the attach script button. And we'll use unit.gd, which is perfectly fine. Again, we can use an empty template and click on create. So what do we want to do for the unit? Well, for now, basically what we do in the first place is to change the image or that region from the sprite sheet when we change the stats connected to the unit, right? That's what we want to implement here. So the first thing we do is we provide a custom class name called unit. Then we'll define an export variable called stats, which will be a UnitStats resource we just implemented. And we'll also provide a custom setter function for this one. Then we'll have a bunch of already variable references. We don't really use the HealthBar and the ManaBar for now, but we'll probably need them later, right? So we can grab a reference to them as well, but we do need the skin and we provide a reference for that. Then we can do this set stats function. And first of all, what we do is we change the stats to the new value we get from the setter. Then we'll check if the value is null, right? Because if we don't have anything set up in the export variable, we don't want to run into errors. So if it's an empty value, meaning we didn't set any stats resources, we just return from this function. Otherwise, it might happen that the node is not ready in the scene tree. Why? Well, because when you call setter functions for export variables, they are called before the scene tree initializes. So if that's the case, we want to wait for the ready signal of this node before proceeding, right? So we only want to change the look of the sprite or the region of the sprite from the sprite sheet when we know for sure that the whole thing is loaded. So when it did, what we do is we take the skin, which is a sprite 2D node, right? Select the region rect property and set the position part of it. It's a rectangle, and for rectangles, you can set their position and their width and height. And we change the position property based on that skin coordinate we have in our stats multiplied by the cell size. So how does this calculation work in practice? Well, we'll see in a second. So let's just save this for now and test it, right? So we can understand how it looks like. Let's go back to 2D view, and you can see that with our unit node selected, we have this export variable here, right? We can assign a unit stats to the unit. First, let's just see if it still works without actually attaching one. So if we run the scene by clicking on this icon or pressing F6, we see our warrior guy in the top left corner and we get no error messages, which is exactly what we wanted. Awesome. But we also want to test it when we actually do have unit stats attached to this unit. So what we can also do is we can create a new resource like this. So let's go back to our file system doc, click on the units folder, right click, create a new resource, and search for unitstats.gd. And we can rename this to Björn because that's how I named our warrior guy. Press enter and double click on björn.tres, click on the name, and we can set this to Björn. And Björn can remain as a common unit, which costs 1 gold. But now we have this skin coordinates property. Let's leave it at 0, 0 first and see how this looks like. So if we click on our unit node, our root node again, we can drag and drop the unit stats we have, like so. So if we save this and run the scene again, you can see that the sprite actually changes. So why do we have this dwarf here? What does the 0, 0 mean? If we click on the skin and expand our texture a bit, you can see in the preview that the dwarf is the first one, right? So you can also see that we have this rect property. This is the region rect we changed from code. And we have 4 values. We have an X, a Y, W, and an H. So the first two, X and Y, is the position, and the W and H are the width and height of the region we want to select, this rectangle. So if we click on Edit Region and select the dwarf, you can see that the position is 0, 0. When we select this rogue elf here, you can see that the X is 32 and the Y is 0. Well, it's because we moved 32 pixels from the top left, right? So you can see the logic behind this. So when we select a Björn here, it will be 32 because we moved away one cell, and it will be 96 because we moved 3 cells downwards, right? So that's the coordinate we're looking for. But in order to avoid the headaches and make these calculations easier, what we did in the code is we just used like a really simple coordinates, right? Like 0, 0. And because we multiply this vector by the arena cell size, actually providing the skin coordinate for Björn should be much easier. So can you guess what numbers should we type here so we get Björn? Let me pull back the image. So what coordinates should we use for Björn if we don't have to provide these multiples? Well, if you guessed 1 and 3, you're absolutely correct. So we want to move from a 1 on the X and 1, 2, 3 on the Y, right? So we can double click on it and change the skin coordinates to 1 and 3. And now if we run the scene again, we should still have Björn as the unit image. Awesome. So hopefully that helped you to understand this line of code here, which changes the coordinate position of this rectangle for the sprite sheet. Awesome. So one thing that would be nice, if we go back to 2D view, if I change Björn's coordinates, so maybe I want to use another one. Let's use a sprite from 3 and 3. If I go to skin, you can see that this one would be this guy right here. So if we click on the unit and reset the stats, it becomes empty. And if we drag and drop Björn, it doesn't really update, but when I run the game or the scene, in this case, it updates. So it would be super nice if this skin value or this region rect would be updated in the editor as well, right? Well, we can use a neat trick for this one called tool scripts, which I haven't used in the previous course. So Godot has this thing called tool script, and the tool script is a script which runs not just when the game is running, but in the editor as well. So all you really have to do is type in @tool on the top to make it a tool script. And if we save this now and go back to 2D view, this script icon should be blue, and it's not. But I guess if we just close the scene and open it again with Ctrl-Shift-O and search for unit.tscn, yes, if we close the scene and open it again, you can see that this script icon became blue, and this indicates that this script is running inside the editor as well, not just in game. And you can indeed see that the guy updates here as well. So if we change this to empty stats now, go back to our Björn resource and change this to 1 and 3 like it was before. If we go back to the unit node and reassign this value, it updates here, but it immediately updates our skin too, which is super cool. I'll include the documentation page about tool scripts in the video description because there are a lot of things you need to be aware of when you run script, not just inside the game, but inside the editor as well. But it's a super powerful tool, pun intended. Okay, so let's save this for now with Ctrl-S. And that's sort of the basics of our unit done. Now we can move on to adding some components to make it more interactive and interesting. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. Okay, so the next thing we do in this video is to add 3 new components to our unit. The thing is with components is that they are not tied to the unit per se. We can reuse them later on elsewhere in the game if we want to. So for example, we do a drag and drop component, which yes, we only use for units for now in season 1 at least, but when we introduce items in season 2, we can just reuse the same drag and drop component. So I know it sounds fancy, but components are basically just scripts. So what we can do is we can collapse the data folder for now, and we can right click on the root folder and create a new one. And let's call it components. And we can dump all the components inside this folder, and we can attach them to wherever we want to, right? So let's right click on the components folder and create a new script. And we can start with drag and drop. So let's name this dragandDrop.gd in snake case and click on create, expand the folder, and double click to open it up in the editor. And before we jump into the coding part, we actually need to define some input actions in order for this to work. So let's go to project settings, go to input map, click under add new action, and we'll call one select, press enter to edit, and we'll call the other one cancel drag, like so. For the select, click on the plus sign, go to mouse buttons and left mouse button. And for the cancel drag, click on the plus sign, go to mouse buttons and right mouse button. And maybe we can bind it to escape as well. So click on the plus sign again, press escape and click OK. Right? We can close the input map and the project settings for now, and we can actually jump into the code part. So first of all, we'll provide a custom class name called DragAndDrop. Then we have the three signals we talked about during our architecture overview: drag canceled, drag started, and dropped. Then we have two export variables. One is a Boolean checkbox because we can enable and disable this component on demand. The reason why this is cool is because if you think about dragging and dropping units, for example, you can do so as you wish in the preparation phase, but we actually want to disable dragging the units around inside the game area when a fight is happening, right? So we can just say that, okay, for all those units, we can disable this drag and drop component when they are fighting, so we cannot drag them around. Awesome. We have another export variable for the target of this drag and drop component, which is an area 2D. So we have our unit as a scene, right? We decide that we want to be able to drag and drop the unit around, so we can just add a new basic node as a child to the unit and attach the drag and drop component script to that single node we added as a child. And then we can set the unit itself as the target of the drag and drop component, and now we can drag and drop the unit around. Super cool stuff. So what else do we need? We'll have three member variables as well. One is called starting position, one is called offset, both of those are vector 2s, and one is Boolean flag for tracking if we're currently dragging that target or not. By default, it's false. So what about the starting position? Why do you think we need the starting position of the dragging? Well, think about what happens when we try to drag a unit from the bench to an invalid position. What do we want to happen? We want it to snap back to its original position, right? Or what about canceling the dragging? So if you started dragging the unit, but you want to cancel the dragging movement, then you also want it to snap back to its starting position, right? So this is why we might want to store the starting position of a dragging movement. And that's exactly why we pass these as parameters to those two signals, right? And notice that the drag and drop component doesn't really care about what the target wants to do with the starting position. It just sort of provides it and says that you do whatever you want to do with that information, right? Then we have our ready callback or virtual method. And what we do is we provide an assert statement. So we sort of throw an error artificially when we have no valid target set for the export variable. And we provide this message that no target is set for a drag and drop component. And then it cannot really work, right? And another thing we want to do, since we know that the target is an area 2D, we know that it has this input event signal, and we want to connect to that signal and sort of decide what to do when an input event is registered on our target. If you take a look at this input event signal, you see that it has three parameters. One is the viewport, one is the registered input event itself, and one is the shape index, which collision shape registered that event. But we don't really care about the shape index because we know that all the units and items and things you can drag and drop around this game won't really have like complex shapes and multiple shapes, and we don't really care about that information, right? So that's why we use this unbind one, because, well, it's data we don't need for that callback function we need to provide, right? Because it's not defined yet. That's why we have this error message. Then we have the process callback, which is called every frame. And this is where the dragging actually happens. So we check for two things basically. Are we in the dragging state? Is the dragging flag set to true? And do we have a valid target right now? If both of those are true, it means that we are currently in the dragging process for that target. Then what we do is we just update the global position to the global mouse position and applying an offset for that position. We'll talk about this offset when we actually test this. For now, you just need to understand the logic, right? If we are in the dragging process, we start dragging the target around by updating its global position according to the mouse's global position. Then we have a couple other methods. One is called end dragging, and this is called, you guessed it, when we end the dragging process. So what do we do when we end the dragging process? We set the dragging flag to false to make sure that the target won't update its position anymore. We remove it from a group called dragging, and we'll get back to this with the start dragging method. And we also change the z index to 0. Why do you think we need to change the z index at all? Again, just think about it and we'll come back to it in a second. Then we have a method called cancel dragging, and you guessed it, this will be called when we canceled the dragging for whatever reason. And we call this end dragging method, which we provided just above, and we emit the drag canceled signal and pass the starting position as a parameter. Then we have sort of the heart of the whole thing, the start dragging method. So how do we start dragging? First of all, we'll set the dragging flag to true, indicating that we started a dragging process. Then we store the starting position of the target, which is the global position when the dragging started. Then I used groups to keep track of whether we're dragging something or not. So what we do is we call target.addToGroup and we add it to the dragging group and set the target z index to 99. Why? Why do we need to set the z index? Do you have any idea? If not, don't worry. When we test this, I'll show you what it does. Then we calculate the offset by taking the target's global position and subtracting the global mouse position from it. This offset is actually there to make the dragging seem less weird. Do you know why? Why does it make it weird if we don't have these offsets stored and applied in every frame? Again, we'll see that in a second when we test it. And finally, when we have everything ready to go, we can emit the drag started signal. So if any other systems want to be notified when something started dragging, then they can connect to this signal. We also have a drop method, which is different from end dragging and cancel dragging as well, right? Because you can end the dragging for two reasons. Either because you dropped at the target position, or you can end the dragging because you canceled it. So it's pretty similar to what cancel dragging does. You call end dragging, but then you emit a different signal, and that's what makes it different, right? So it really matters which signal we emit. Was the drag canceled or was it ended because it was dropped? And finally, we can define that on target input event callback. And if you remember, we connected this to the area to these input event signal. And that's the reason we called unbind1 here, because we have two parameters, the viewport and the input event, and we don't need the shape index. Right, so what do we do? First of all, if the drag and drop component is disabled, meaning that the enabled property is false, then we can return from this immediately because we don't want to do anything with drag and dropping if the component is not enabled. Then we can get the currently dragging object by calling getTree.getFirstNodeInGroup dragging. Why do we need this? Why do we use groups at all? Then we have the safety check code if not dragging and dragging object return. Let's think about this because this might seem confusing. What does this whole thing mean? Well, think about the scenario when you have multiple units on your bench. What happens then? Do you want to start dragging a unit when you're already dragging another one? The answer is probably no, right? So you only want to be able to interact with one draggable object at a time at any point of the game, no matter if units and items are both involved. You only want to drag one thing at once, right? So what we do is we create this group called dragging to keep track of all the units or items or whatever it is we are currently dragging. And if you remember, when we started dragging, we add the target to this group. So if we have two units and we start dragging the second one, then that unit will be added to the dragging group. The reason why we sort of query for getting the first node in this group is because if this component has not initiated a dragging process and we do have something else that is dragging, then we can return from this because we don't want to interfere. Does that make sense? Hopefully it does. So this is sort of just to check whether that thing happens where we drag the first unit and we would start dragging the second unit because we hover over it, and then it would get a bit confusing because it would start the dragging process for that as well. Maybe we can disable this when we're testing and you'll see the artifacts it causes. But if we don't have anything interfering, then we need to handle 3 different cases. If this component is currently in a dragging process and we press the cancel drag action, then we need to call the cancel dragging method, right? Otherwise, if this component is not in a dragging process and the select action was pressed, then we need to start dragging. And finally, if we are in a dragging process and we released the select action, then we need to drop our target. This one hopefully makes sense. I think it's pretty straightforward, sort of separating those 3 actions. This one might be a bit confusing, so we'll see about that in a second. That's all the code we really need for a drag and drop component. We can save this with Control S. And if we go back to 2D view, we can test this, right? So let's select our unit, our root node, press Control A to add a new child node and search for node because we only want to add a simple node. We can double click and rename this to drag and drop. And all we need to do is to drag this script from the components folder and drop it over our node script. And if we click on this one and go back to the inspector tab, you'll see that we have our 2 export variables, the enabled property and the target. So if we click on target and assign, we can select the unit as the target area for this component. And that's the cool thing about this. So we can basically do the same thing for items in season 2. We can just smack a node, slap that script on top of it, and it works out of the box. So let's see if it works or not actually. So save this scene by pressing Control S and press F6 to run this scene. If I hover over a unit, press and hold left mouse button, I can actually drag it around. I can drop it. If I drag the unit around and press right click, no matter how I move the mouse, the unit cancels the dragging process, right? And it should work the same way with escape. So if I start dragging and press escape, but for some reason, pressing escape doesn't work like right click does. Maybe I forgot to edit. Let's go back to project settings and input map. Yeah, I forgot to add cancel drag. Maybe I clicked on cancel instead of OK when I selected it. So let's click on the plus sign again, press escape and click on OK. Now it's there. Yeah. So let's close project settings and run the scene again. So it should work with escape as well. And it still doesn't. Okay, that's weird. But now it's there. And if I run it, it works with right click. But it doesn't really work with escape. So let's investigate why this doesn't work. If we go back to our drag and drop components script, what happens here? Can you guess why it doesn't work? So let's do some live investigation. If we go back to 2D view and select our unit, our area 2D, and go to node and signals, we have our input event, right? So if we hover over this, it says emitted when an input event occurs. Okay, click on input event for details. Accepts unhandled input events. So my first guess here is that for some reason, pressing the right mouse button or clicking with the left mouse button is registered by this area 2D, but for whatever reason, keyboard input is not. It's not considered to be an unhandled input for some reason. And it also says, if we go back to the inspector, we have this input for collision objects and input pickable as on. And here the documentation says A pickable object can detect the mouse pointer entering, leaving, and if the mouse is inside it, report input events. Okay, so this should be true technically, but I'm guessing that this has something to do with this unhandled input event, and this mouse needs to be inside business. So my first guess to fix this would be to actually don't just do cancel dragging here, but if we want to provide the escape key as well as a possible way to cancel dragging, I would do something like overriding the input callback, which is not the unhandled one, but all input events, and do something like if we are currently dragging and we do have a target and the event we received is the cancel drag action pressed, then we can cancel dragging this way as well. So with these 3 lines of code, I guess when we run this scene now, we can still cancel with right clicking, but now if I press escape, you'll see that if I move the mouse, if I keep the mouse moving motion, the dragging is canceled. So I guess this solves the problem. I'm not sure if I want escape to be there as a cancel dragging mechanic. I don't think it's worth doing the extra effort. One thing we need to be mindful of is if you want to provide a pause menu, for example, which is triggered by the escape key as well, then this might cause problems down the line. So you know what? I just get rid of this. It's a solution. If you want to keep escape as a cancellation mechanic, you can do so. But for now, I'll just leave this as is and go back to the project settings and remove the escape key. We solved the problem, but I don't really like sharing the same key with the pause menu. I guess it could be done. I don't know. For now, I'll just leave this as is. Okay, so let's save this. And we see that now we can say that it works. Okay, so we investigated this issue, but I can drag this dude around and I can cancel, I can drop wherever I want to. So it kind of works. So let's test those things I was talking about. So we were talking about the offset, why we need this offset. So let's go back to 2D view. And if we go back to the arena, let's scroll all the way back. And if we select the arena and instantiate a new child scene, let's put a unit here. Press W to go into move mode and move this unit around a bit. Okay. So if we play in the arena, you can see that everything works fine. If I drag the unit around, it's always visible. And I can do everything I could when we just tested the unit itself. So first of all, let's see what this offset does. So if we go back to our drag and drop component, one thing we can do is when we add the offset, we can just comment this line out. And if we don't set the offset, it will be a 0 vector by default. So adding a 0 vector as an offset actually does nothing, right? So if we comment out this line only, we can see what it looks like without the offset. So if I start dragging this dude right next to his right hand, I click and drag. Did you see what happened? What's that? See, the problem is that the coordinate of this unit is right here, right? If I start dragging, we immediately update the global position of that unit to be the same as the mouse cursor. So if I click here, you see that snap. If I click here, it snaps there. So what happens is there's this jarring jump when we start dragging, then it looks fine. So after we start dragging, it looks fine. But when we start the dragging, there's this like teleporting the unit to the top left of the mouse. And we don't really want that, right? So if I start dragging the unit here, we should feel like if I grabbed it by its leg or something, right? I don't really want that extra snap to happen because it looks jarring. So what this offset does is it calculates the difference. So if we uncomment this, It takes the target's global position, which is the top left corner in case of the unit, and compares it to the global mouse position, which is in this case, if I click right there, it's here, right? And subtracts the two vectors from each other, and we get the difference. So when we drag the unit around, this distance between the two vectors will be applied, so it will look like I moved this unit by its hand, right? So if we save this and test the scene again, you can see that when I click on his head, there's no jumping around, and I can start dragging, and it looks like I drag him by his head, right? The same with the hand. You see? In the offset applied, it drags from that position, and it looks and feels much, much better. It's a small little thing, but it adds a lot in terms of UX and in terms of game feel. Okay, so the other thing we were talking about is the z-index. So what about this z-index? If we uncomment this z-index 99 and run the game, everything looks fine, right? There's no problems. So why do we need this? Well, let's go back to 2D view. And let's say that we add this unit to the game area, right? So this unit will be inside the game area because it's on the battlefield. But what I can do is I can grab this unit and move him back to the bench, right? So if I move him back to the bench, what happens here? Well, if you take a look at the scene hierarchy right here, the order of the nodes matter, right? The lower a node 2D is in the scene hierarchy, the higher priority it has in terms of drawing. So what it means is that the bench is rendered in front of the game area, which is not a problem by any means, but when we do have units inside and we start dragging them, then it becomes a problem, right? Because we always want the dragging thing to appear in front of everything else. And we want to make this completely independent from the scene tree hierarchy, because if I drag a unit, it doesn't really matter if it's under the game area or the bench. I still want that thing to be on top of everything else when I drag it. So this is why in the drag and drop component, we have this z-index. When we start dragging, we set it to a big number to make sure that it's rendered on top of everything else. And when we end the dragging, we set it back to 0. So if we save this and run the game again, you'll see that now it won't get rendered behind the bench, right? It's on top of everything else. Pretty cool. We still have that problem when we actually end the dragging. We set it back to 0. But this won't be a problem later on, because when you drop it to the bench, we'll have the logic to actually reparent this unit under the bench, right? So when we drop it, it should look like this. And when it looks like this and you release it, it won't be drawn behind those tiles, right? Hope that makes sense. Pretty cool. So that's why we have the z-index. And another thing we were talking about is this business right here, right? This putting them inside the group and providing the safety check, which might seem a bit confusing. Okay, so let's see what happens if we comment this out, save this, go back to 2D view, and duplicate this unit a couple of times and move them next to each other. So now what happens is I start dragging this unit. And if I press the left mouse button again, I can drag them basically together like so. And I can't even get them to separate. It's really hard because they have a kind of overlapping collision box. So do you see what I mean? So I start dragging this, the dragging flag becomes true, right? The drag and drop component activates and I'm dragging this unit. But if I release it and immediately click here again, then we have two collision boxes which can pick up this input event signal, right? So technically I could start dragging all of those. And that's a problem because I don't want to be able to do that. I only want to drag one thing at once. So that's what we sort of want to establish with this reasoning, this logic here. So if we run the game again, no matter how I try to move them closer together and drag them all at once, I can only do one, right? I'm trying my best to move them at once, but I can't. And you can also see that the Z indexing works when I start dragging because this unit is behind the other ones, but when I start dragging it, it will be rendered on top of everything else. So that's why we need that, because otherwise I would be able to stack them together. You might argue that we don't really need this because this is a tile-based game, right? So when we have the grid system in place, these units will be separated from each other, which is true, but at the same time, if we run the game again and go to not project but debug and turn on visible collision shapes and run the game again, you'll see that even if we put them exactly on the grid, their collision boxes might overlap. So I deliberately picked a bigger collision box size than the unit just to make it a bit more easy to click on units and hover them and swap them around, right? It's a UX thing. So if we don't have this piece of code, you see that this overlapping area becomes a problem because I would be able to drag both of those at once. So it's safer to do this safety check to make sure that we can only drag one unit at all times. Awesome. And I think that's it for this video, and I guess I'll see you in the next one. Bye-bye.